Hello everyone, welcome to Eduxcite classes. My name is Monit and welcome to the series of A.2 forces and momentum. In this video, we'll talk about the Newton's laws of motion, all three Newton's laws and the questions related to it. Okay, so it's a small request to please share this video as much as you can with all your friends and the classmates. That's the purpose of making this video, and you can, if you have not watched all my previous video starting from the A.1 kinematics, you can check the playlist. The link is given in the description. Okay, if you want one-to-one session or if you have any doubt, you can scan the QR code to chat personally with me. Please avoid the odd times. Okay, and before we move on, you can also find out the PDF of this worksheet. The link is given in the description. Okay, so a small recap of what are the Newton's laws of motion. So you just pause the video and have a quick read. Okay, so sometimes they may ask you to state the Newton's laws of motion. So make sure that you use these laws for writing down your answers. Now in this particular video, I will be using one equation for the Newton's second law, which I generally says that the F net will be equals to driving force minus resistive force. Now why I am saying this, because I will constantly be using these terms throughout my videos, so you should be aware of what does this stands for. So F net is nothing but mass times acceleration. Driving force are the forces which act in the direction of the motion. So as we progress through the video, we'll get to know how to define a driving force in a given condition. And resistive force are those forces which are opposing the motion, which acts in the opposite direction of that of the motion. So in short, I write dF and Rf for, this is a Newton's second law motion, and I made this equation to use to solve those particular problems related to C. Okay, so that was all. Now starting with the very first question, pause the video and solve. Now if you look at the first part, now a man is standing still. Okay, so what are the forces acting is, the weight is acting in the downward direction and the normal reaction force will be act in the upward direction, which I denote as R. So it is standing still, so the normal force, or I will denote normal force as R, so that it did not get confused with the unit of force Newton. In some of the book it is denoted by N, but here I will follow the notation as R. So the normal force will be equals to the weight, and for simplicity I am using G as 10 meter per second square, but make sure in your exam you are supposed to use 9.8. okay, so normal force will be equals to weight, which is equals to 70 times 10, which is equals to 700 Newton. So that's the answer, quite easy. Yes. Now the B part, it moves with a constant speed. Now whenever the object is moving with a constant speed, the acceleration will be 0, because there is no change in velocity, so acceleration is 0. So F net is 0. So whether it is moving up or moving down with constant speed, the forces will remain same. So you can say at constant speed, that is acceleration is 0, therefore normal reaction is equals to weight again equals to 700 Newton. That's the answer for the B part, right? Now C, it is moving up. This is very important, moving up with an acceleration of 4 meter per second square. Now if the object is moving up, right, so the force which is acting in the upward direction is my normal reaction force. So this will be my driving force, as I mentioned in the introductory part of the video, and this weight will be my resistive force, because the object is moving up and the weight is acting in the downward direction. So if it is moving up, I can write using the Newton's second law of motion, that is R minus W will be equals to ma, right? So R we have to find out, m we are given, acceleration is given, so it will be ma plus W. So m is 70 times acceleration is 4 plus weight will be m into G, which is 700 Newton, right? So if you solve for this, you will get 700 plus which will be equal to 9.8 times 10 raised to power 3 Newton. You have to answer in a scientific notation like this, okay. Always remember, whenever you are supposed to answer, give an answer in a scientific notation, okay. So this is the answer for the C part, and then the D part is asking it is moving downward with acceleration 4. So just now it is moving downward, so my driving force will be the weight and resistive forces this time will be the normal reaction. So I can say moving down, I can write moving down, it will be W minus R equals to MA. So you can just put up the values. So this time R will be equals to MA, or you can say R will be equals to W minus MA. So I have put 700 minus 280 this time. So you will do the calculation, you will get the answer as 4.2 into 10 raised to power 2 Newton. I have already done the calculations, okay. So this will be your answer for the D part. I hope you have understood the part question number 1, all the parts. If you have any doubt, just comment below, okay. Now try the question number 2. Pause the video and solve. Okay, so draw the forces on the person. So if I have to consider the person, the weight is acting in the downward direction, right? It is holding the rope, so there will be a tension in the upward direction, and as it is standing on the elevator and it is in contact with the surface, so there will be a normal reaction force, which I can say it will be R, like this. So this is the point of contact. So these are the forces. You can draw tension in the upward, or R plus T also you can show. Now for the elevator, if you see the elevator, this is the person. So WP stands for weight of the person, and here you can see this will be the weight of the elevator in the downward direction. There will be one more tension because the tension is connected with the elevator also, right? So this tension will be there in the upward direction as well, and due to person standing on the floor this time, for the elevator the normal reaction force for due to the person will be in the downward direction. So this R will be also in the downward direction. So this will be the force body diagram for part A and B, okay. Now in the part C, the question says the elevator is accelerating upward, okay, with 0.5 meter per second square. Find the normal force on the person from the elevator flow. So what we can do is, we can make out the equation using the Newton's laws of motion, the C part. So for the elevator accelerating upward, so I can say if it is moving upward, I can make out the equation like T plus R minus WP is equals to mass of the person times acceleration, right? And I can also make equation for the B part is T, because it is moving upward, minus R minus WE is equals to mass of the elevator times acceleration. So they both will be moving the same acceleration. So mass of the person, mass of the acceleration, mass of the elevator and acceleration is known to us. Okay, so what we can do is we can add these two equations, equation 1 and equation 2. So you should know how to frame the equations. If you have not watched my previous video, in that also we have discussed, so you can watch that as well. The link is given in the description. So if I add equation 1 and 2, it will be 2t, this r and this r gets cancelled, then minus WP minus WE is equals to mass of person plus mass of elevator times acceleration. So where we can find out the value for the tension, right? And then using that we can find out the normal force on the person from the elevator flow. So let us first find out the acceleration. So 2t will be equals to, this person weight is 70 and the elevator is 30. So this is 100 times 0.5 plus 70, and for simplicity I am taking GS 10. You have to take 9.8 for your examination. So this will be, weight of the person will be 700 plus weight of the elevator is 300, right? So if you solve for this, you will get, this will be 100 times 0.5, which will be 50, right? Yeah, 50 plus 700 plus 300. So this will be 1050 equals to 2t. So t will be equals to 525 Newton, right? 525 Newton. Now use t in equation 1, I can write 525 plus r minus 700 is equals to 70a. Now a is again 0.5, we know this. So if you solve for this r, I have already done the calculation, it will come out to around 210 Newton. So that's the answer for the part C. Okay. Now similarly, if the person exerts on the elevator of the floor as 200 Newton, find the acceleration of the elevator. Now what is given is the force that exerts on the elevator floor is already given, that is the normal reaction force, that which is 200 Newton. Find the acceleration of the elevator. So what we can do is we can make a combined equation. So as a whole system, that is the two tensions are acting in the upward direction minus the weight of the person, which is 700 plus 300, which is 1000, is equals to the mass of the person and the mass of the elevator, that is 100a. So this will be my equation 3, let us say, and using the equation mass of the elevator, which will be, or mass of the person, I can use r plus t is equals to minus 700 is equals to 70a using equation 1. So if I use this equation, I can find out the acceleration. This is given to us as 200, right? So if I use this equation and if I multiply this with 2, so and then adding, or you can say subtracting equation 4 minus equation 3. So it will be 2r minus 1400 140a. So this will become, you can write down 2r plus 2t minus 1400 plus 2t minus 1000 is equals to 140a minus 100a. So this will be minus, so this and this gets cancelled, right? So you can directly find out 2 times of r is given to us as how much? 200. So 2 times of 200 minus will be plus, this will be minus 400 equals to 40a. So 400 minus 400 equals to 40a. So acceleration will be 0. So it means that the lift is moving, or the elevator is moving with a constant speed. So acceleration comes out to be 0. It means that there will be, when the normal reaction force is 200 Newton, the elevator is moving with a constant speed. So do not get confused with the weight here, because it is holding the rope as well. So that was a good question. If you didn't get it, rewatch the video, and even though if you have doubt, just comment below. Okay. Now try the question number 3. Pause the video and solve. Okay. Now if you look here, for maximum, let us start with the largest value of m, small m. So largest value of small m means the block will move in this direction and this will move in upward direction, right? So, and they are not supposed to move. So, for largest value of m, the block of 15 kg has a tendency to move upward. So, the friction will act in the downward direction, right? So, here for largest of m, I can say, if I want to draw the free body diagram, so this will be mg, this will be tension remain the same in the same row, and this will be mg sine 25 plus nu mg cos 25, because of this will be mg cos 25 and this will be normal reaction force, and the friction is equals to nu r. So, for largest value of m, I can say is T is equals to mg, no doubt, and the second equation I can write is T will be equals to nu mg cos 25 plus mg sin 25, and T is equals to mg, so mg is equals to, this will be as it is, right? And here you can say g is taken out and gets cancelled, and this will be capital M, to be very, this g and g gets cancelled, and small m comes out to be, nu is given 0.4, capital M is 15 cos 25 plus 15 sin 25. If you solve this, you will get the value of small m. For the largest value of m, I have already done the calculation, near about 12 kg. Okay, it's quite easy. I hope you have understood it. Similarly, what will happen is, when I just add a page here, yeah, for largest value of m is clear. Now, for smallest value of m, what will be there? Let me copy the diagram. Now, I can say for smallest value of m, in that case, the block will move upward and the capital M block will move downward. So, the friction will act in the upward direction. So, I can draw mg and this as t, this will be t, here it will be mg sin 25, but the friction will be nu mg cos 25 will be here. Rest all will remain same, so I can make out the equation as t is equals to again mg, and the second equation I can say is t plus nu mg cos, again capital M it will be, my mistake, this will be capital M. So, nu mg cos 25, this will be equals to capital mg sin 25, and t can be written as small mg plus nu capital mg cos 25 equals to capital mg sin 25. Again g comes out in common, so here you can say the m, small m will be capital M sin 25 minus nu capital M cos 25. Now, when you put the values, you will get 0.415 sin 25. When you put the smaller value for m, I have already done the calculation, it will be near about 0.9 kg. So, that will be the answer for your smallest value of m. I hope it is quite clear why we are using the static, because they are not moving as of now, but for largest smallest value, the direction of the friction will change, and accordingly your answer will be different for the small m. Okay. Now, question number 4, now I will just explain you, these are the different cases. If you have understood and able to solve these type of problems, then you are very sufficient in solving any other types of problem. So, I will just explain you in terms of what the question is. So, block of mass m1 whose value is 9 kg is lying on a table over a pulley with a thread tied and with the other end has a mass m2 of 4 kg. You have to use G as 9.8. The kinematic or dynamic coefficient of friction is 0.15 and the static friction is 0.2. What you are supposed to find out in all these problems is you have to find out the acceleration of each block and the tension in the rope. These two things you have to find out. Now the upcoming questions will also have the same acceleration and the same type of question where you have to find out the same acceleration for the each block and the tension for the rope. Okay, so pause the video and try to solve. Okay, now if you look at this case, again I will draw M2G. This will be tension, tension will be here. Always tension is away from the object, that I have discussed in my previous video. If you have not watched, check the playlist in the description. Here it will be M1G and normal reaction R1 I can say, right, which will be equals to M1G because the vertical forces are balanced. Now first you have to look whether the object will move or not. Now how to look? For simplicity I can say M2G, right, M2G is 4. Taking just to check whether this will move or not, I am taking G as 10. So this will be 40, right? So if it is not moving, then the tension will be equals to the weight of the block. So tension will be 40 Newton, right? Now tension will be 40. So what static coefficient of friction is 0.2 and M1 is into 90, right? So 0.2 into 90 is how much? It will be 18 Newton. So 18 Newton is very less. It means the friction, maximum friction that can be exerted for the block M1 is almost 18 Newton and the applied force is 40 Newton. So definitely the block is supposed to move. So M1 will move in this direction. So let us say it is moving downward and this is moving with acceleration. Now both will have the same acceleration and the tension will be same throughout the rope. Now if I want to make equations, I can say again M2A is the net force for block M2 is equals to driving force, which is M2G minus T. So this is my equation 1. Similarly for M1 I can make out the equation as driving force will be my tension, or let us say net force is M1A. The tension is in the direction of the motion, so driving force is tension minus there will be a friction here and this friction is nu into R1. So nu K because it is moving into R1, which is M1G. So I hope it is quite clear how I made the equation 1 and equation 2. If you have watched the video from starting, this will be quite easy. Now what I will do is first I will find out the acceleration, and using the acceleration I can find out the tension. So adding equation 1 and 2, you will get M1 plus M2 times A is equals to M2G, T and T gets cancelled, plus T and minus T minus nu K times M1G. Now acceleration, if you put all the values, M2G minus nu K M1G divided by M1 plus M2, you just put up the values, you can get the answer of acceleration. I have already done the calculation. Acceleration will come out to be near about 2 meter per second square. Okay, now using if you can use this acceleration and find out the tension use A in equation 1, the tension will come out to be, you just have to put the acceleration value here, you will find out the tension. So the tension will be M2A plus M2G minus M2A. So if you find out this, you will get tension something around 31.21 or 31 Newton. So this will be your answer for your question number 4. I hope it is quite clear. Just do the calculation in your calculator, you will get the same answer. If you have any doubt, just comment below. Similarly, in the same manner, you have to find out the acceleration and the tension in the row for question number 5. Pause the video and solve. Okay, similarly now what will happen is, again you can check whether it is moving or not. Here it is already given that this one is moving downward. You can check using the same method as we discussed in the previous part. Now only the difference is now it is an inclined plane. Now we know that in an inclined plane always there will be one component of the weight which will be m1g sine theta 1, I can say. Here it will be m2g, tension will be away from the object, and for m1 it will be like this. Now if it is moving here, the friction will be nu into r1, and r1 will be here, and r1 will be equals to m1g cos theta 1. Because I have enough practice, so I can do just like this. So just you have to find out, make out the equation. So equation will be, it is moving in this direction with acceleration a, here it is moving in this direction with acceleration a. So for m2 I will write t minus m2g is equals to m2a, equation 1, and I can write down the equation 2 as m1g sine theta 1 minus t minus m1g cos theta 1 equals to m1a. Now you can use the values nu times m1g, wait, it will be minus nu k times m1, because nu into r1, and r1 is m1g cos theta 1. Now you have the value of nu k, you have m1, you have m2, you have theta 1, you have g. So if you solve for these equations, again you can add these two equations. Adding equation 1 and 2, you can write m1g sine theta 1 minus nu k m1g cos theta 1 minus m2g is equals to m1 plus m2 times a. Now you have all the values of these, right? You can just put up the values as per the given question. You will find out the acceleration something around 0.94 meter per second square. I am not doing the calculation here. You can do the calculation in order to save your time. You can pause the video, you can do the calculation, and you can find out the answer. Similarly, put A in equation 1, you will get tension something around 53.7 Newton. So I hope it is quite clear. Just try these type of question. If you are able to solve these, you can definitely solve any other problems. Now similarly, now both the play objects are in an inclined position. Pause the video and try to solve. Okay. Now in the same case, here it will be m2g sine theta 2. Here it will be m1g sine theta 1. Now in the given it is moving in this direction, you can check using or you can assume any direction. If the answer is coming in negative, it means that whatever the direction we have considered, the actual direction is in opposite, but the magnitude will remain same. So don't worry how to choose whether it is moving m1 side or m2 side. Even if I choose this side, then I will get the answer in negative. But I know here m1 is 20 and m2 is 6. It's quite easy to understand, or you can compare as well. So this will be tension here, this will be tension will remain the same. So this will be R2, right? And R2 will be m2g cos theta 2. Here it will be m1g cos theta 1. And this will be R1. So friction will be F1 will be here, and for here it will be, because it is moving here, friction will be F2 here. So if I equation for M1, let us say for M1, equation will be what? It will be, the driving force is what? M1g sine theta 1 minus tension minus nu k is same, M1g cos theta 1 is equals to m1a. So this will be my equation 1, right? Now similarly for m2, I can write down here the driving force will be tension minus m2g sine theta 2 minus nu k m2g cos theta 2 is equals to m2a, right? So we made the equation for m1 and m2. Now you just add, so tension and tension will get cancelled, so you can find out the value for the acceleration a. Here also we have to find out the acceleration and tension only. So adding equation 1 and 2, we get the acceleration as something around 1.7 meter per second square. I already done the calculation for you. Just pause the video and do the calculation to find out acceleration. If you have any doubt, just comment below, or you can even download the PDF. Okay, now using use A in equation, any equation I use for 2, you will get tension something around 38.59, or you can say 38.6 Newton. I hope it is quite clear for question number 6. Okay, now solve question number 7. Pause the video and solve. Okay, now in the A part, we have to find out the largest force that is possible for both the masses to move together without sliding on each other, right? So first of all, let us draw the free body diagram for the upper and for the lower as well. Now if I want to draw the free हाँ, अब बोलो, टाइम लगेगा क्या आपको?
नहीं, मेरे को तो पेपर दिखाना था।
तो अभी टाइम लगेगा, फिर मैं आता हूँ। ठीक है, ठीक। So we have to draw the free body diagram for the lower as well as for the upper block. So let us say this is my lower block. So force F is applied and friction is between the two blocks, right? So F is here, the weight is downward, and a normal reaction force, let us say R, is acting in the upward direction, and of friction, because this block will move here, so the friction for this block will be in this direction, friction. Okay, now similarly for the upper block, let us say this is R2, and for upper block this will be, there is no applied force for the upper block, but when this block is moving, this block has a tendency to remain in a state of rest due to its own inertia. So it will try to move in the backward direction as compared relative to the bottom one. So the friction will act in the forward direction. So friction will be here, its weight, this is weight for block, let us say this is 2, this is W1, and a normal reaction force R1 will be acting in the upward direction, right? So I hope the free body diagram is quite clear, and also there will be R1 acting in the downward direction for this as well. So here I can say vertical forces are balanced, so R1 is equals to W1. So R1 will be equals to W1, which is taking G as 10 as of now, G as 10 Newton per kg, right? So R1 will be W1, which is the upper block. So this is 6 kg, this is 4 kg. So this will be 40 Newton, right? And here I can say R2 will be equals to R1 plus W2. So R2 will be, R1 is 40, W2 is 60. So R2 is 100 Newton, right? So this is how we find out the normal reaction forces. Now if we want to find out the force, I will make an equation F minus friction is equals to 6A, and for upper block I can say friction is equals to 4A. Now using this, so F minus 4A is equals to 6A, so F will be equals to 10A. Now acceleration and friction will be equals to nu into R, right? So this weight, what I can say is this A I can find out, or friction I can say is nu point 0.6 into R1, which is 40, is equals to 4A. So this will be 24 equals to 4A. So acceleration is equals to 6 meter per second square. So largest force will be equals to 6A plus friction, right? And friction is 24. Or you can say 6 times 6 plus 24, 36 plus 24 is equals to, so the force, largest force will be equals to 60 Newton. So this will be the answer for your option A. Now option B, subpart B, the F is in the previous example now is 80 Newton. What is the acceleration of each block? The coefficient of dynamic friction is now 0.5. Now instead of 60, now it is 80. Now they are supposed to slide over each other. So the equation will remain the same, but the frictions and the value for acceleration will be different. So F minus friction for this will be 6A1, and the another equation will be friction is equals to 6A2, right? So I can say is friction for this will be how much? I can say this will be nu 0.5 is into R1, R1 is 40 is equals to 6A2. So this will be 20 is equals to 6A2. So A2 is equals to 20 by 6. So 20 by 6 is almost equals to second upper block is a 4 na, so it will be 4A2. So 20 by 4, 5 meter per second square. And similarly for A1 you can do friction. So force is 80 minus nu is 0.5 into friction for this will be friction for this will be again 0.5 into 40, which is 20, 0.5 into 40 into 6A1. So 80 minus 20 is equals to 6A1, 60 equals to 6A1. So A1 is equals to 10 meter per second square. So this will be the acceleration for the lower block, and this will be the acceleration for the upper block. Okay. Now if you compare the acceleration, the lower block is moving with the higher acceleration as compared to the upper block. So as a result, relatively the upper block will be moving backward if you compare with the lower block. Okay. I hope I am quite clear. Now try question number 8. Pause the video and solve. Okay. Now this is quite easy. What is the acceleration of the each block? So when the blocks are combined, you can say that we can consider this as one complete block. So x is 2, y is 6. So 2 plus 6 is 8. So I can say 24 is equals to 8a. So a will be 24 by 8, which is 3 meter per second square. This is quite easy. Yes, because they are joined together, so we can consider them as one block. Now determine the force x exert on y. So how much force x is exerting on y? So there are two ways. Either you can find out the net force on the, so that is nothing but net force on y. So y will be equals to 6a, that is F equals to ma. F net is equals to ma, and this will be F exert 6 into 3, which is 18 Newton. Either you can do like this, or some force will be taken for the acceleration for the block x. So x is equals to 2. So 2 into a is 6. So 6 Newton will be taken by the object x. So the remaining will be exerted on y. So 24 minus 6 is again 80 Newton. Okay, so either way you can solve. This is one of the simplest question, but you should know the concept, otherwise it will be quite difficult. Okay, try question number 9, pause the video and solve. Okay, now if you look at the tension in the string joining the two masses, so what I can do is I can draw the free body diagram. So for 30 kg I can say this will be F and this will be T. There is no friction mentioned, so we will assume as frictionless. So and this is moving in this direction with acceleration A. So I can say F minus T is equals to 30 A, and for the 10 kg I can say this is 10 and this is 30. I can say only tension is there, so I can say T is equals to 10 A. So I can write down tension in terms of A. So F is minus 10 A is equals to 30 A. So F is given to us, so 60 is equals to 40 A. So A comes out to be 60 by 40, which is 1.5 meter per second square. So we find out the acceleration using A. Use A in equation 1. Equation 1, T is equals to 10 times 1.5. So tension is equals to 15 Newton. So that's the answer for the part A. Quite easy, right? Now the question in part B says that if the position of the masses are interchanged, will the tension change? Yes, there will be change in the tension, because now it will be, you can say, now in this case you can say for B part, let me make some space. Yeah, so for B I can say this time if 30 comes back, so T will be equals to 30 times of A. Now acceleration will remain the same because the system is not changing. The acceleration of both the object is the same. If you can find out acceleration, you will get the same value, right? So in this case the acceleration is again 1.5. So 30 times 1.5, if you do, the tension will be 45 Newton. So you can see if the blocks are interchanged, the value for the tension is changing. So if the heavier block is after this at the end, then the tension will be more in the rope as compared to when the heavier block is in front. Okay, so I hope you have understood question number 9. If you have any doubt, please let me know. Now for the MCQ, I only find one MCQ in your past year paper related to this, but yeah, definitely paper 2 is basically covering these topic. So paper 1 MCQ is very limited for the Newton's laws of motion, or they may ask you for certain conceptual based on Newton's third law. So if an object A is exerting a force on object B will also exert a force on object A, but in opposite direction, equal in magnitude but in opposite direction. So based on this Newton's law, you may find certain pairs of Newton's third law. I will request you to please go through any of your textbook, that whatever the reference book you are following, please go through and have a reading, so that will give you a broader idea about the pairs of the Newton's third law of motion. So for this, just pause the video and solve. Yeah, the answer for this is question number first MCQ is A. So you can just draw the free body diagram. It is mentioned that the capital M is greater, so it is moving in this direction. So I can say small mg is equals to the, and capital mg, and tension remains the same. So I can make out the equation as mg minus t is capital Ma, and t minus small mg is equals to small ma. So adding these equation, so capital Mg minus small mg is equals to capital M plus small m times A. So A will be, G is common, m small m times G upon capital M plus small m. Option A is the right answer. Okay, so I hope this particular video gives you a better understanding of how to solve the questions related to Newton's laws of motion. Small request to just share. If you found it useful, please share with your friends and the classmates, so they will also get the benefit. You can download the PDF of this video. The link is given in the description below. So that's all from my side. Keep learning. See you in the next video.